So my hope is if you're watching this video, you also watched the last video on my channel, because in the last video we dived into structs versus classes versus actors, and the whole reason we did that was to get a deep understanding of what actors are. And so if you don't know at the beginning of this video, I mean, you're welcome to continue watching, but I highly recommend watching the last video first and then coming back to this one. In this video, we are going to dive deeper into what is the problem that actors solve? Because actors are relatively new to Swift and they were added for a reason. They're solving a very specific problem, and I'm not going to tell you what that is, because if you don't know, that means you didn't watch the last video. What we're going to do in this video, we're first going to address the problem. We're going to recreate the problem without an actor. Then we're going to solve the problem without an actor. This is what we would have had to do if we didn't have Swift Concurrency. And then finally, we're going to introduce an actor. We're going to see just how awesome, powerful, easy actors make our lives.
All right, welcome back everyone. I am back in our Xcode project. I'm about halfway through this course now. I'm feeling good. I'm feeling back in the game here. It's been a long time since I was making YouTube videos. Those first couple of videos were pretty tough, especially the last one we just did. We covered structs, classes, and actors. That was a very heavy, difficult video to make, and that gets us over the hump. The rest of these videos should be much easier than that. In this video, we're covering actors. We briefly learned what actors were in the last video. If you were not with me in the last one, watch that one before this one. The last video really explained what actors are. In this video, we're just going to dive in more on how to actually use an actor rather than what an actor is. So let's right-click the navigator, create a new file. It's going to be a Swift UI view, and let's call this one Actors Bootcamp. Go ahead and click create. Once we are inside, let's get coding here. And what we're going to do in this video, there's three parts to this video. Firstly, we are going to look at what is the problem that actors are solving. Secondly, we're going to look at how was this problem solved prior to actors, because actors are relatively new. So there obviously were ways to solve this problem before actors. And then finally, we're going to do an example that really outlines just how easily actors can solve the problem. All right. So what is the problem that actors are solving? And the problem really is a data race problem. It is when two different threads are accessing the same object in memory. So what we're going to do is first actually recreate the problem. All right, I'm going to try to move fast here because there's a lot of setup that we have to do in this video. Basically, we're going to create a tab view, and we're going to create two tabs in our app. Let's just put it as a text that says hi for now. Let's give this a tab item, and we'll use a label. Let's use the system image completion here with system image. First screen, let's just call it home screen. House.fill will be our icon. Let's copy that and make a second one. And this one is going to be browse. Let's give this a magnifying glass. Cool, we got our tabs down here. Let's just make sure the tab bar is working. I can click this. Awesome. Let's create two views for this. So up here, let's create a struct. Let's call this one home view. Conform to view. Every view needs a body. Let's make it a Z stack. Let's give it maybe a background color of color dot. Let's do gray. Maybe opacity 0.3. And let's ignore the safe area. Let's put the home view on the screen as our first tab, see what that looks like. Let's give it maybe 0.8, make it a little darker. And then I'm going to create a second screen and call this one the browse view. Let's do maybe color dot yellow. Same deal. We'll put this one down here as our browse view. Let's make sure we can switch between these tabs here. Cool. And these are going to be super simple views just to outline the problem here. So what we're going to do is create an @state private var text of type string. set it equal to a blank string, and then we'll create a timer. We'll say let timer, we'll set it equal to a timer dot publish. We'll publish every 0.1 seconds. We don't need a tolerance. We're gonna run it on the main loop. We're gonna run it in the common loop, and options will be nil. Let's auto connect so that it starts as soon as this view is created. On the screen, we're gonna put a text that obviously has our text. Let's give it a font of maybe headline. And on this Z stack, we're gonna call it .onReceive. So every time we receive a value from a publisher, this timer is a publisher. It's publishing a value every 0.1 seconds. So let's receive values from that publisher. And then every 0.1 seconds, we're gonna get this new value here. We're not gonna use the new value, so I'll just put it as an underscore. But every 0.1 seconds, what we wanna do is call a function in a shared class. And that class is going to be shared between this view and this view. So up here, I'm gonna create a class, and I'm gonna call this one my data manager, open brackets. So let's make this one a singleton. So we'll add a static let instance, and we'll set it equal to my data manager. So this will be a single instance that we use for this class across our whole app. Because it's initialized inside this class, we can just add a private init like this, so that this is actually the only place we ever initialize one. I have a whole video in my advanced series why I do not recommend using singletons like this, but for this example, it is by far the easiest way to go about it. All right, so in my home view, I'm gonna get a reference to this instance. So we'll say let manager, we'll set it equal to my data manager.instance. What we're gonna do is simulate some data that we would have in our actual app, right? So our data manager probably manages some data. So we'll create a variable and call it data, and it will be just an array of string for now, and we'll set it equal to a blank array. Let's create a function in here called maybe get random data, and this function will return us an optional string. What we're going to do every time we call get random data, we're going to do two things. First, we're going to add some random data to this array. So we'll say self.data.append, and we'll just append a uuid.string. This is just generating a random string, and we're going to append it to this data array. And then we're going to return data.random element, so a random element from this data array. While we are in this function, let's also just print out the thread.current, the current thread that we are running on. All right, so on my view here, every time we get a publish, every 0.1 seconds, let's try to get some random data. And if we get random data, let's update our text. So we'll say, so in here we'll say if let data equals manager dot get random data. So if we get random data, we'll set self.text equal to data. All right, before we move forward, let's see if this is actually working. So I'm gonna click resume on the canvas here. It does look like we're getting our changing user UIDs here. I'm going to build this to a simulator. So let's take our actors bootcamp view, make it the first view in our app. Let's build this to a simulator. I'm going to an iPhone 13 here. And the reason I'm doing that is because I want to get that printout where we are printing the thread.current. All right, so our view loaded up here. Every 0.1 seconds we are getting a publish, and we can see that every single printout here says it is on the main thread, and that's thread number 1. And so that's kind of what you probably expected. We're running this all on the main thread. We never did any background threading here, and everything's working fine. There's no problems in our app right now. What we're gonna do is basically mimic what we're doing here, but also do it on the browse view. So I'm going to take my manager, my text, my timer, copy and paste them down here. Let's add the text to our browse view, and let's add this on receive to our browse view as well. Let's change this one to actually every 0.01 seconds. So these will go at different cadences, but eventually they will be occurring at the exact same time because they will publish at the exact same time. And let's build our app one more time. We are going to load it up. I can go to my browse view. It looks like it's working. I can go to my home view. It looks like it's working. All of my printouts are, again, still on thread number 1, and that's why I don't have any problems yet. But in our actual apps, a lot of times we are using background threads, and we don't have any in this example because we're not actually using any kind of URL session. We're not going to any server and actually downloading anything, but we could. And if we did do that, we would go onto a background thread to do that downloading process. So to simulate that, what we're going to do is, before we call get random data, let's go onto a background thread. So we'll say dispatch queue dot, let's use a global thread. I'll make this one maybe in the, let's do the background. We'll call async. And then we're going to do this action in the background thread. And we know as good developers that if you're in a background thread and you come back and you want to update your UI, you have to go back to the main thread. So we'll add a dispatch queue main async here, and we'll go back onto the main thread. I'm going to copy this and do it on our browse view as well. Except this one, let's do a different background thread. Let's do a let's do the default background thread. Why not? So let's build this to the simulator. We're going to get a bunch of printouts here. Let's see. I'll pause this. So just looking really quickly, we can see a whole bunch of threads that came through. Thread 6, we have thread 9, thread 4. Later we went down to thread 10, 12, 13, 17, 19, 30, 41. Tons of threads opened up in our app here. And the important thing that we know as developers is that these threads are all accessing the same class. And we learned in the last video that classes are not thread safe. So if two threads access the same object in memory at the same time, you can run into really bad problems in your app. You can run into data races, if not worse, crashes. Now, as we ran this, we didn't get any error message. The app was still running. And this is probably a very common situation in apps, especially beginner developer apps. A lot of times you don't even know that your app has potential threading issues in it, especially if you're not aware of these problems. Luckily, Xcode actually has a hidden thread sanitizer that we can use. So if I come up here to click edit scheme, the scheme that we are currently in, and I turn on the thread sanitizer, it's turned off by default. If I turn on the thread sanitizer, close this, and build this one more time, the thread sanitizer basically checks the thread safety. And as soon as we run it, I can see some funkiness printing out here. I'm going to pause the app. So we get the same thing that happened, except we got this massive warning that printed out down here. Warning, Swift access race. We are modifying a variable at this pointer. Remember in the last video we talked about references and pointers. So you'll notice that this pointer, same as this pointer, but you'll notice here it's getting accessed by thread 5, here it's accessed by thread 1. The bottom line here is that two different threads are trying to access the same piece of memory in the heap, and that is a problem. That is a data race. I guess it comes down here, thread 1 and 5. I'm not really sure which threads are causing the problem, but we know what the problem is. Multiple threads are accessing the same class. All right, that's the problem. We do not want this in our app ever. If you do have this in your app, this is probably one of the hardest things to debug. But now that we understand the problem, we can start to address the solution. So firstly, the question is, without actors, how do we solve this problem? We have two different places in our code, and in your app, you might even have more than two places that are accessing the same class from different threads. Well, the first step is to take this class and try to make it thread safe. So how do you make a class thread safe? Well, basically, you make everything in this class run kind of on the same thread or on the same queue. So how we did that before we had actors was we would create some sort of queue specifically for this class. So I'll do like a private we'll call it queue, and I'll set it equal to a dispatch queue. Now you'll notice dispatch queue, same word that we use down here. So when we go onto the main thread, we dispatch onto the main. We go into a background thread, we would dispatch onto the global. And then here we can actually just create custom queues. So I'm going to create one with a label, and I'm going to call it similar to like a bundle ID. I'm going to call it com.myappname. And I'll call it my data manager. So that will be just the name of the queue that will come up in the debug logs. And the question then becomes, well, how do we use this queue? Well, when we go to do anything in our actual app, let's go onto the queue first. So before we do this, we'll call queue.async, and then we will do all of this code inside our queue. Looking good so far. The problem we then run into, of course, is that we can't return out of here because this is now an asynchronous block. And as we discovered earlier in the series, well, the old way of getting out of asynchronous blocks is with completion handlers. So we would have to then add a completion handler. Let's make it a function that returns void. And the completion handler, I'm going to give it an underscore, and let's call this maybe returned title, and it'll be of type string. All right, this function is no longer going to return a string. Let's actually make this open and close parentheses. I think that's more common. And then instead of returning the data random element, we are going to call completion handler and then add in our data.random element. I think we have to add the word self here. And that's pretty much it to make this class thread safe, at least for now. If we had a whole bunch of different functions, they would all need to be on the queue. Basically, we were taking all of our code inside this class and putting it onto this queue. These queues, I often call them queues. A lot of people like to call them locks. So sometimes you'll see people refer to this as a lock. Let's go with that for now. And now we're going to call this from our code. So coming down here, instead of get random data, we'll say, instead of calling it and returning data, now we have to call manager.getRandomData. We have our completion handler. And then we'll take our code, we'll check for the title in here. We'll say let data equals the title that's returned. And we should be good to go. I'm going to copy this and do it down here in our other view as well. So now we have kind of the same situation, both of our different threads running. We have our thread sanitizer still active, and we can run this. And I'm getting an error message, and that's because we need to declare the parameter as escaping. So we'll use an @escaping here. All right, hope I'm not losing anyone. We're gonna build this one more time. Same situation, same class, except this time the class is now thread safe. And you'll notice when we run it, that nasty warning error is not showing up here, right? So that's pretty much the solution to making classes thread safe. It is purely put all of your functions into a dispatch queue, a lock or a queue, and then they will be thread safe. Because this will basically, when all of the functions reach this line, they will basically get in line here, right? So if you have a bunch of functions, they have to asynchronously wait for the other one to be complete before the next one happens, because they're all lining up inside that queue. That's why this works. This is much better code than what we had in our last example. But of course, now we are getting into actors. And so more or less, an actor is a class that does this automatically for us. And because we are in the asynchronous Swift concurrency environment, we no longer have to use completion handlers either. So what we're going to do is copy this and paste another one down here. I'm going to call this one my actor data manager. Still going to have a singleton. This one will be my actor data manager. We're still going to have data, but this time we're going to get rid of our dispatch queue. Instead, we're going to make this an actor, and we're going to revert back. We're going to get out of this lock, so I'm going to cut this. And we don't need our completion handler. And we're going to go back to a function that returns an optional string. Nice and simple, how we had it at the beginning. And then we're of course going to return our random element here. All right, let's start using my actor data manager instead. So I'm going to come down here in my home view. I'm going to use my actor data manager. In my browse view, I'll use my actor data manager. And as I've discussed in this series multiple times now, when we are using the asynchronous environment, we no longer want to use dispatch queues, and instead we should be using tasks. So what I'm going to do is just comment all this code out. I'm going to comment all this code out as well. So let's call manager.getRandomData. We can see this is an asynchronous function that returns us a string. We can't use it yet because we are not in a function that supports concurrency. So let's jump into a task. Let's call manager.getRandomData. It's asynchronous, which means we need to await on it. It is returning us a data. So we'll say let maybe data, we'll set it equal to getRandomData. We can see that this is an optional string, so let's just do an if let. And if we get the data, let's then switch back onto the main thread. So we'll await the main actor.run, and we will say self.text equals the data. I'm going to copy this task here, paste it down here on the browse view as well, and let's build our app. All right, we are running. We still have our thread sanitizer turned on, and we are still on multiple threads, as we can see in these printouts. But again, we don't have that crazy thread warning happening. So what we did was basically, instead of using a class that is thread safe, we can now just use an actor. And we can see just in this code is much easier to read than this code, right? And you could imagine if these were more complex, right? Making sure we are always working on this queue or this lock. There's a lot of room for error if you ever forget to call this. Every time you do call this, you then have to add these completion handlers. So you have all these crazy completion handlers across your app. And things get quite complicated. Instead, we use a nice and simple actor. Actors are thread safe. We don't have to worry about all of that. And the magic of the actor is really happening in the await keyword. So up here in the class, every time the code gets to this async block, it is basically being added to this queue and then waiting its turn in order to go. And instead, the actor, since we don't have this async block, when we get into the actor, we are actually calling await before we get into the actor. And so we are waiting to get into the actor, which is more or less the same thing as this, except it's super easy to write in our code. We just have to await. Being in the actor, we get to use tasks, and our code just ends up being much quicker, much cleaner. And overall, I hope you now understand just how powerful and important actors really are. For a beginner developer, changing the word class to actor is super simple. And you might think that's all you need to do, and then you can use actors, but you probably don't really understand what they are doing. And here we have a pure example of how an actor is solving one of the trickiest problems in any multi-threaded environment, any kind of app across the board. This is a very tricky problem and a very great solution. All right, and the final thing that I want to leave you guys with is, so every time we want to access something inside the actor, we then need to await to get into that actor, right? And that's because all of the code inside the actor is isolated. It is isolated to that actor so that it is then thread safe. So for example, if we wanted to just get this data from our view, if we wanted to run a function, maybe we do like an onAppear. We can call manager.data. We can see the data, it is asynchronous. Now, the actual data itself is not asynchronous, but in order to get it from down here, it's going to be an asynchronous task. And that's because we have to await to get into the actor before we can access the data. So in order to do that, we would have to do something like task, and then we would have to await on the data. And for the data that is going to actually be shared and needs to be isolated to that actor, this is a good thing. This is a safety thing. We are happy to await to get the data, but there may be situations in your app where you have some code in your actor that actually does not need to be isolated to the actor for whatever reason. Now, it's probably a rarer case. So for example, maybe we have another function in here that says maybe get saved data, let's just say, and it's a function that returns a string. But maybe instead of like accessing this shared data that is being saved inside the actor, maybe it's just going to return us some new data. And maybe in this function, we're not really worried about thread safety because we know we're just going to get this returned new data back. So the question then becomes, if we want to call this function that is inside the actor, but we don't want to await to get the data, how do we actually do that? So right now we would call manager.getSavedData. Everything would work. This would say our let new string. We can see that we're going to get the string back. But if we want to take this function and then actually make it so that it is not isolated to the actor that it is in, we simply mark it as non-isolated. And that's why I've been saying the word isolated for the past 2 minutes. A lot of people will write it like this, where non-isolated is its own line. I personally do it often like this. But basically this means that this function is not isolated to the actor, meaning we don't have to await to get into the actor in order to access this. So coming down here, instead of having to go into the concurrent environment, we can just say let new string, and we'll set it equal to manager dot. And you'll notice already that the stuff that is in the actor that is isolated is grayed out, and that's grayed out again because we're not in a context that supports concurrency. But the getSavedData function is not grayed out, and that's because it is no longer asynchronous because it is not isolated to that actor. So then we can use it. And similar to creating functions, we can also create constants. Let my random text equals something, right? And so if we want to access that, we would call manager.myRandomText. We can see it's normally asynchronous because it is isolated, but we can mark it as non-isolated as well. And now we can access my random text without having to get into that actor. It is important to note though, once you do have something that is non-isolated, you can't just access the isolated functions from the non-isolated. So in here, if we wanted to say let data equals get random data, we will run into this problem that, of course, get random data is actor isolated and can't be referenced from non-isolated context. So the non-isolated keyword is pretty handy. It is probably more handy when you start using global actors, but we have not learned that yet because we are learning that in the next video. So for now, all I want you guys to know is, firstly, what is the problem actors solve? And that is the data race problem. How did we solve that problem? Before actors, we use dispatch queues, locks, or queues inside the class. But now, even better than that, we can just use an actor, and actors are thread safe by default. They are thread safe because we need to await in order to get into that actor. And if we are ever doing something inside an actor that does not need to be isolated to the actor, we simply mark it as non-isolated. All right, that's my video on actors. Hope you guys learned something. If you did, please don't forget to hit the subscribe button, leave a like, and leave a comment below. The next couple videos are just as important as this one. I hope to see you guys there. In the next one, we're going to cover the main actor, which is the main actor which we've been using throughout this course, as well as some global actors. It is going to be a lot of fun. I hope to see you guys there. Thank you guys for watching. As always, I'm Nick. This is Swift Thinking, and I'll see you in the next video.